So I guess we are ready to start. Hi, Dr. Ghosh. Welcome.
Hello, thank you for having me.
Thanks for accepting our invitation. Let me introduce you to the audience here, and then I'll give the floor to you. So Dr. Reshmi Ghosh is a applied scientist at Microsoft Research. She's also on the team for Microsoft Copilot. She's exploring security risks associated with LLMs at Microsoft. She's also giving conferences at different NLP conferences all around the world. And she also has research collaborations with different universities, including UMass and MIT. And she kindly accepted to give a talk on AI safety, LLM safety. Her talk is entitled Ensuring Safety in LLMs, Tackling Responsible AI Harms and Prompt Injections. So thank you for being here, and I'll give the word to you.
Cool. Let me share my screen very quickly.
Okay.
Okay, I think. Let's see. Can you see my screen?
Not yet. Now is, yeah, we can now see.
Okay. I'm gonna go into slideshow mode, so hopefully this does not change stuff. What do you see right now?
Only this slide.
Only the slide, not the speaker notes and the other.
No, we only see your slide.
Okay, awesome. Cool. Thank you so much for having me here. It's obviously an honor to speak to you all about some of the responsible AI concerns and security risks that we have been thinking very deeply about, given that LLMs are kind of brittle. So the talk would be about like the general perspectives that we have gained. I do want to give out a disclaimer that this talk will not involve any Microsoft confidential information because I'm not allowed to talk about that. But that's it. Let's get started. A little bit about me. I am an applied scientist at Microsoft, and I'm also leading the effort to think very deeply about how we can use some of the machine learning, natural language processing information and knowledge that we have about LLMs to make sure that the products that we are building, which is the whole suite of like Microsoft M365 Copilots, more secure. I have also been involved in architecting some of the copilots. If you have been following any of the news that Microsoft released in the past of one and a half, one-ish years. So I've also been involved a lot on the engineering side, on just like thinking more deeply about how do we even build a system around utilizing generative AI capabilities. And before that, I was in Microsoft creating, developing, researching NLP features for productivity applications, which is the Office group of products, PowerPoint, Word, Excel. I think it was also already mentioned, I'm also like a research mentor. I do mentor research collaborations in different universities in the US. Some of them are University of Massachusetts and Amherst, Boston University, MIT, and UCLA. And before joining Microsoft, I finished my PhD from Carnegie Mellon University. And I'm also very, very passionate about making sure like women in STEM feel more empowered to come into the AI field. And I work very closely with women in machine learning and science to have those kind of like collaborations and events to make sure that everyone gets a platform to learn more about like how do you venture into the field of AI. These are some of my social media handles in case you want to connect with me later on. So let's start quickly about responsible AI principles that we had in Microsoft. And I want to start with this slide because we are definitely riding the generative AI wave right now, but responsible AI is something that has always been part of our product life cycle. So Microsoft has been at the forefront of responsible AI, establishing principles that have guided our approach long before like generative AI even became the talk of the town. And we were committed to deliver fairness, reliability, safety, accountability, privacy, and transparency through our products. And these are like some of the key principles that are ingrained in our product lifecycle, which means that whenever we are thinking about products, whenever we are thinking about engineering products, building these from scratch, we do think about all of these principles and think more deeply about like what are the consequences of not getting something right? Like how can we make sure that we are testing enough, we are doing our due diligence to get the products right on these responsible AI principles. And these principles are pretty much like aligned with a lot of like governing agencies like NIST, who create their own responsible AI frameworks. So there is a lot of work done to ensure that if there is a gap in the coverage of principles, those are updated, and we stay on top of like updating and making sure every concern that we need to address for deploying any machine learning feature, not even generative AI feature, that is well taken care of. And we do this just to make sure that we are adhering to an ethical standard and also promoting like equitable and secured technological landscape, right? So this dedication to responsible AI innovation stems from the belief that technology should empower everyone around the globe and respect user privacy and maintain like higher safety standards. But that said, with the advent of LLMs, I think it was quite clear with the kind of news articles that broke out, and a lot of discussions that are happening across different forums, different groups, Reddit, Twitter, social media, that LLMs are brittle. And we must acknowledge and address this growing concern of reliability, because we know that these are brittle structures, but they're extremely useful. And there are articles highlighting the concerns around hallucination, that AI is not just outputting like relevant stuff, but also like vague random outputs. And it's a challenge that needs to be tackled. And we need to figure out things to like detect these hallucinations better. And we are working on it. We are working on like making sure that the system that is responding to user requests is actually providing a safe haven for the users to continue that experience. And this conversation about LLMs being brittle, there's the hallucination aspect of it, the safety aspect of it, is actually extending to a lot of like policy and regulatory concerns. And there are some governments who are becoming increasingly conscious about how citizens in their country are using AI. And they're trying to figure out like what is the best mechanism of like exerting the right amount of control on the AI technology due to the fears of the potential risks. And we're also seeing like practical examples of like chatbots outputting really crazy stuff. And this highlights like some of the missteps that are occurring, and how we want to make sure that these are accounted for and everyone is responsible while developing some of the conversational bots comprehensively. Just talking about like the brittleness aspect of AI and like why this is such a big talk of the town, why did it become so important suddenly? I think at the end of 2022, when ChatGPT was just released, the thing that changed the technological, the world of technology was the fact that for the first time, there was a chatbot, a platform for users and human beings to interact very closely with LLMs and actually visualize their capability in day-to-day tasks, for search, for writing, rewriting, also like even looking up for like certain things on the internet. You wanted to make sure that that whole process of going through like multiple web pages is now streamlined to like one interface, and the bot or the LLM does the job for you. And this kind of interaction was extremely enriching, which is what made everyone around the world towards the end of 2022 like stick to the use of ChatGPT, to the use of like any other conversational bot that is being released, like Bing Chat. Because this kind of interaction basically saved a lot of time. But what was forgotten, that this, unless explicitly accounted, during the model training, because these are essentially like language models. Or you can also think about it in like multimodal model, which has like both language as well as image outputs. These are trained on like large swaths of data. And when you're feeding that data as part of like the training process, there's often no explicit instruction given to the model, or there's no weighting mechanism on like what is good and what is bad. So the model being the model and like just taking in text and trying to output text, it does not have a good understanding to differentiate between what is an appropriate content and what is an inappropriate content. And thus, when anyone is like interacting with generative AI, we must confront the critical issue that user experience can suffer due to the unpredictable nature of language models. And the inability of the language models to differentiate between good and bad content without explicit guidance or post-training refinement is a risk that the model could generate like content that is harmful to the user, that is triggering to the user, is biased or profane in any way. And there's also risks of like other security concerns, right? Like, for example, I talked a lot about like content related harms, which are like text output or like any output that is triggering to the user interacting with these bots, or some any kind of harmful experience can happen. But there's also a risk of like the model actually outputting something that it should not, because it was supposed to be secure. So there's the concern of data exfiltration, like someone actually hacking into a system, because large language models are brittle to the kind of like instructions that are passed along with it. So thinking very deeply about these experiences, we want to make sure that when we are building products, and this is not just related to Microsoft, like everyone in the industry is thinking more deeply about this. We are thinking about the risks that this model entails, and how do we basically amplify our defenses against the generation of any sort of content harms, as well as any sort of like security risks that is going to create any IP content leakage or any data exfiltration, or any sort of like the traditional security risks of state actors trying to get information out of enterprises. And this challenges actually underscore the need for meticulous development and monitoring systems of AI, so that we align with the values and the expectations that we want our users to have. And thinking more deeply about the responsible AI framework, this is something that I think was always in use. It has been modified for large language models, but if we closely look at the strategy to deliver AI products responsibly, it has never been very different from the frameworks that were previously built for deploying any machine or deep learning based solution. So we start by understanding or defining the value principles that we want to make sure that the users will have the best kind of experience. And these principles basically ground us on our moral compass, and sets the stage for like what we consider to be like ethical or responsible in the context of AI. So there is a lot of work that needs to happen in just like making sure that you're defining the right principles of like what exactly is a harm and what can trigger users. And this requires like reading up literature, understanding cultural nuances, because what is a harmful content in the US may not be harmful in Turkey, or like vice versa. So you have to understand the cultural nuances that comes into context when you're thinking about harms. There are other regulatory policies across geography. So like all of those needs to be taken into account while creating these values or these verticals of guidelines that we need to like follow. And once these values or principles has been set up, the next focus is to like figure out the goals. Like based on these values, like what is the goal that you have to deliver a product with some kind of like desired outcome and we want to achieve, right? So for example, like if you have a chatbot that you're building and you want to think more deeply about, hey, this chatbot should not be doing anything that kind of like harms students who are using it. So the goal here would be to make sure that students interacting with the chatbot is not accidentally like looking up random information on the internet, that can be considered as like a method to like copy or like plagiarize, right? So that is a goal. And like you need to think more deeply about like the goals that you have while building any sort of like AI product. And once you have defined the goals, then you have the step of like requirements, where you are basically thinking more deeply. It's breaking down the steps to realize those goals. Like, hey, if the goal is to make sure that students don't plagiarize using the chatbot that you're building, what exactly are the requirements to ensure that that goal is achieved? So think more deeply about like the breakdown of that structure in a more engineering way. And then you lastly like find out like tools and practices to like enable that requirement, right? Like now that you have a requirement to like figure out that any of the students should not plagiarize, and like they should be using this chatbot in a way where, for example, like you cannot upload any of the previous content from the same curriculum that has been used in the past, just to make sure that you're not looking up for like other students responses or exams. In that case, like you have to figure out a way to like filter down the content or like detect content that can be considered as plagiarized, right? So like you're thinking about the tools over here that is required to make sure that specific experience is enabled. And these tools are like consistently evolving. Like I give an example of plagiarism, which is like very, very, very low risk. There are different forms of AI harms, like for example, because the language model is like text in, text out, you can think more deeply about the fact that you can basically make the model output swear words, but we don't want the model to output swear words, because at that point the users would feel frustrated, annoyed, they will feel offended by the kind of like language the model is outputting, and that is not good user experience. So thinking more deeply about the outcome, that we want to prevent any sort of like generation of any profane or like swear words from the model, what is the tool that we use? And a lot of focus right now, I think, which is like from Microsoft and even across the industry, is like building those tools in a correct way. And I have a few examples of the tools that I think Microsoft is building. They are open source. There's some of them are like also services that you need to pay for, but it's something worthwhile to like read more about. And I have links towards the end of the presentation. Now, talking about harms, right? Like I briefly mentioned plagiarism. I briefly mentioned harmful content from any sort of chatbot. But there could be like harms that are manifesting, or like they're being forced out of the LLM in different ways. So because the language models, as we discussed earlier, does not have a good recognition capability of what is a good content, what is a bad content, based on like how the training was done, it can directly manifest content harms. Like, for example, you tell the large language model to query or like output certain profane language, or like say like you want to use a certain word that is offensive, and it mostly would create it, unless like it has been layered with defense strategies. So if you have tried out ChatGPT, you will see that if you try to make it create any sort of like profane content or like tell it to swear, it will not, because there has been refinement in the way that that app has been deployed, right? So it's the same thing. So we have to first think more deeply about like what are the kind of harms that can arise from these AI interactions. And content harms, these fields like continuously evolve, but some of the things that are important, I think personally, are things that can directly trigger a user. And it could be profane content, it could be violent content, it could be sexual content, it could be hateful or unfair language, it could be leakage of intellectual property, it could be anything that comes off like as a personal or like as a cultural bias, because you don't want to like affect any minority groups. And such range of content can inflict a lot of damages and emotional distress to people interacting with these bots, and that basically can translate into like financial and reputational losses for the company who's building that chatbot. Now, along with the direct manifestation or the direct generation of these content harms, the other kind of harms that can happen once you have also like layered some of these large language models with instructions to not output something is there could be a jailbreak, which can then like indirectly manifest content harms. And one of the terms that got really famous during this whole process of like LLM and like hacking into LLMs is called prompt injections. Prompt injections are basically like instructions which are sent along with the user query. Like my query supposes like summarize my email, or like write this long document into like something else. Along with this query, you can like pass along instructions which is essentially designed to like break into the system and hack the system to like not follow the tuned version of like this is like not outputting something that is violent, but instead, because of those instructions, because of the prompt injection, now the LLM will go away from the desired behavior that we wanted to include and will start outputting more profane language. So thinking more deeply about the fact that how these content harms can even like be generated is an important step towards designing like effective mitigations for the conversational bot. So you can imagine like here on the screen, if you see there's the query, and you inject with the query some instructions to make sure that the conversational bot is not supposed to adhere to like whatever it was told previously. In fact, like about something like, you know, like don't output, if there's an instruction in the system prompt saying don't output a certain word or don't output a certain phrase, which is a swear word, there could be instructions that is trying to manipulate that. And there has been cases where the LLM actually has ignored system prompt instructions and has adhered to this set of like prompt injection instructions and created something harmful. So this is an example of like how we think more deeply about like the fact this is not just about like types of harms that are generated, but also about like the ways and mechanisms in which the harms could be generated. And I think once, now that we have talked about like what exactly the generation of these harms entail and like the mechanisms in which the harms entail, I think it's important to also talk about like how do we even prevent harms in generative AI. Now, this is like a general framework that I think we in Microsoft follow, but it's also like applicable to any chatbot. And I think there are other frameworks of the similar structure that is being followed in other tech companies as well. So in basically addressing the prevention of harms in generative AI, our approach is being proactive. So the first step is like map out, identify the potential types of harms that can come from a generative AI model. And when I say types of harms, like suppose if you have a model that has been trained on more English language, there's a possibility that it will only generate like harmful content in English rather than like a more multilingual model. There's also this possibility that some models in the training process were weighted appropriately, where the harmful content was basically somehow like instructed to the model while the pre-training process happened that it should not output a certain type of language, or it should not output a certain type of phrase. That is, you can read more deeply about something called instruction fine-tuning. So there are mechanisms of doing that, but that means that there are also like models right now which is being researched upon on how at the model level itself there could be different mechanisms on preventing those harms. So in those very like safer models, the process would be very different, and you may or may not see the same kind of harms that you find from like a more generic, more open source language model that is being trained on like any kind of public data. And once you have like mapped out those harms that can manifest from these language models, I think the second key component is to make sure that you're measuring the possibility of these harm generation. Like it's one thing to like know that, oh, our model is susceptible of generating a certain kind of harm. The other part of the problem is to make sure that you're measuring in a more data-driven way how many times is it possible to like generate a certain kind of harm. So there are mechanisms, and I'll go through that. There's a paper that I've linked on like how to do automatic testing of the kind of generative AI harms that can be manifested from the language model that you're using or the application that you're building, and how to measure it effectively, because you need to get the data set right and also make sure that you're running it over a large enough sample to draw out like very specific conclusions. Once you have measured that there is a certain kind of harm that can happen from the application that you're building using large language models, the next thing is about mitigation, because now you know that, hey, our model is susceptible towards generating a certain kind of content. How do we make sure that this is mitigated so that the people who are going to use your applications are basically not creating something that it should not, or like seeing something it should not. And there are open source packages on like making sure there is a layered way of like defending the model to not generate certain kind of content. Or you can also think more deeply about the fact that while you can include certain kind of instructions in the system prompt so that the model itself knows that, hey, when I'm generating a certain kind of content, this should not be followed. But all of those mitigations also have its own like nuances and like caveats. So it's important to figure out like how can we actively build on top of one mitigation until we have achieved the kind of experience that we want to. And the last step of this process is observe. Like once you have like mapped out, you have measured, and you have like figured out a way of mitigation, and you've deployed it with your conversational bot, your goal is to figure out like over a course of time, is the model regressing on certain kind of like harms? Would that mean that this mitigation layer needs to be like revamped again, or you need to like add more mitigations to it? And if not, like is your model doing, or the application doing as you had expected? And I think this comes very much directly from the model observability a component of any machine learning feature. You across time, you want to see like how good your model is and like how well it is performing. Obviously there's no model retraining over here, but maybe you want to retrain based on like the model size, or kind of like small model versus large model that you're deploying. But that said, like you also observe for like newer kind of harms that are being generated, right? Like one of the process is to also monitor this whole realm of large language models and the kind of content harms it can generate over time, because this is a new technology. We're just like scratching the surface and like figuring out like how things work. So it's important to create a system that can actively detect newer threats that needs to be addressed, but was not addressed in the first sort of like map, measure, mitigate process. And you want to include those continuously and figure out like how do we keep up with the new threats that are being discovered, because there are a bunch of hackers, there are a bunch of state actors who are continuously like red teaming. Red teaming is a process of like injecting or trying to force bad outcomes from any application. So there are people who are trying to red team who for sometimes for the good, sometimes really for like affecting the reputation of your brand and your company. So you have to keep on you have to be one step ahead of those hackers, because you want to fix the gaps that can be evolving at a later time. And when thinking about like just this whole mitigation process, like like I said, the models can be tuned to a specific way based on the cultural nuances, for example, for the data that you have, or for the type of audience you're building. That, for example, if it's students versus like corporate employees, like how do you think more about like the data that the model should or should not output? And you can make model level changes by doing like some sort of fine tuning on the NLP model or the large language model or the small language model, whatever you're deploying. But also, if you want to keep the model isolated and you don't want to spend on just the fine tuning process because it is expensive, sometimes you also have to think more deeply about like layering the system with like other mitigations or guardrails, as we call it, to add more safety towards the application layer. Because the LLM or the whatever model you're deploying, that's just like the core of the application you're building on top of, right? So outside the core, you can have ways and mechanisms of like making sure that, hey, like how can we like even do some sort of like easy rejects match to catch any sort of swear words. Like it can be a solution as easy as that. So building those applications on top of that model layer, it's like an onion. So like the model is at the core of the onion, and like everything that you add on top of it is a peel. You layer those defenses, and like you make sure that you are going towards that specific outcome that you wanted to you wanted your users to experience. I think that is how the entire process of like figuring out the right mitigations work. So it goes back, it is a back and forth process between like the map, measure, mitigate, observe, and coming back to monitoring, and then address any gaps over time as your feature is released, as you do more red teaming, as you figure out like, hey, this is a new threat, like some hacker basically discovered a new way of exfiltrating into your system. So like you want to like figure out those gaps, and you want to keep a tab on it, and you want to continuously like improve upon your service. This is just like the last few slides where I'm highlighting like some of the tools that has been developed by Microsoft. There's a lot of active research in this area. Like I think like my team also like works very closely on like the academic side of the research side of it, as well as like productionizing stuff. But there's these are some of the things that you can read more deeply about. The first link is just like how everyone in Microsoft is thinking about like responsible AI research. Azure AI Content Safety is one of those services which is now being developed inside Microsoft to give customers a way of amplifying the defense. So the content safety has a bunch of like different tools which you can use to like make sure that you are protected against content harms, you're protected against generation of any sort of like content harms via prompt injections. And then there's the third link is actually like a paper that is on automated testing, which maps back to the measurement process. Like if you have built a system and you've mapped out all the harms that can come from the system, what is a good way of creating a data set and automatically like measuring it in a way so that you can figure out like what is the frequency or the probability that these harms would actually come out from your application. And there are a few other links on like how people are thinking about the best practices, as well as like how to evaluate LLMs better, which is the fifth link is not really related to like RAI per se, but it's related more so about like just making sure the content that is generated from LLMs is like up to the mark, and like it's not hallucinated or is not corrupted in any way. Yeah, I think like the final slide that I have is this is, I personally feel, is super important in developing any generative AI products. We are building products for everyone across the world to use, right? And there are many nuances that a human being feels, which may not be generally represented if you're talking to only a small group of people. So culture, when your culture in the company where you're building these products plays a very important role in making sure that you're getting the product right. I grew up in India, and then I moved to the US, and I know that I can see there are certain cultural nuances which is different in India versus the US, and something that is acceptable in India may or may not be acceptable in the US. And how do you make sure that you are including all those different thought processes in your product to basically enable the product for maximum usage across a group of people is what we are striving to achieve right now. And that means that we should be talking to more people more often. If there is something that you feel like, oh, this model is not outputting in a manner that I feel very comfortable with, or I feel like there is something which is wrong in the content that is generated, it's important to raise those points in the group that you're working with, because fostering that environment of inclusivity and allowing everyone to talk about how they feel about even building the product, that will ensure that the product is actually successful when it's deployed. And it's like it's given out to users to use it. So I think the development aspect and the people who are developing these products are also as important as the people using it, because a lot can happen just at the development phase, where you can recognize harms, you can recognize gaps in the system, and you can talk more openly about it and talk more and being more inclusive about like things that are not okay for you but maybe okay for others, and vice versa. I think that's the last takeaway that I wanted to share, because it's just so important while developing these generative AI products. But that's it. That's the end of the presentation. I wasn't monitoring the chat, so I think I am happy to take any questions that you have right now.
Thank you for this fascinating talk. I'm sure it's interesting to every one of us here. So if you have any questions, you can unmute yourself and ask your question, or you can post your question in the chat.
Hi, Reshmi. May I have a question? Is it okay? Yeah, so it's interesting to hear that there's too much stuff going on and there is no single protection of all. I'm checking for some time what can be the mitigations, etc. But what I'm after is mostly, do you think that all these protections should be baked into the foundational model, or do we need a separate model just for protection? The reason I'm asking is this: sometimes people think that okay, we tried LLM, foundational model, we have a product, but then you end up with the security part. And if you have yet another new LLM that you have to add into the system gets complicated, slow, expensive. There's so many stuff that when you add on top of the base model. So my question is, what do you think is like? Do you foresee that the protection should be baked into the base model, or do we need separate models?
Yeah, that's a really good question. And two, I don't think that everything needs to be baked into the base model, because the base model is obviously serving the purpose of like creating that experience of being more productive, like answering in a certain manner, helping you write emails, summarizing documents, whatever you want to do it, right? But it doesn't have to be even like a LLM call. Like I think I gave an example of like how if there are certain phrases that you want to filtering using like regex matching, using a lexical string match, that also works. So I think we have to think more deeply about like what are the consequences of putting everything into the LLM versus actually think more deep, versus think more about like how it can be layered. And I think the layering aspect is what is going to help us create experiences that are more secured, because at no point the LLM itself will be good enough to protect against everything. So I think that's where the whole conversation is about. And if you look at, I can paste it on the slide, there's a good link on Azure OpenAI models that basically are OpenAI models, but being serviced through Azure, which is Microsoft's cloud service. They have this concept of like, how do you even like think about layered differences or layered defenses? So I think that's the future. It's not always about like adding it to the base model.
Thank you.
Hello, can I also ask a question?
Yes.
Okay, great. Thank you so much for your presentation. It was very informative. The question I will be asking is about like there are a lot of activity around LLM application development, and but when you look at like what's going on, it's really like applying, I don't know, fine-tuning RAG, so on and so forth, and the community is trying to find its way to make useful products. but as we all know, like security is very important. But do you think LLM security right now is like not the main focus? Because personally, I think it's very important. But from what I observe, is like the community is trying to get adapt to LLM application development models, so on and so forth. So of course there are people like dealing with LLM security, but my question is like, do you think sufficient enough attention is being put on LLM security right now? The attention that it really deserves?
Yeah, I think that's a great question. I can't talk about, because I don't work in other tech companies, on how they're viewing it, but at least I would say that there are two things happening. One, there is obviously a craze about generative AI, and everyone's building products, right? So it means that people who were also not familiar with like traditional LLP models are now coming in and like building their products because it's easy to build. It's an API, and like you're building on top of it. So there is that differential in the education, but at least like from what I can say within the Microsoft environment, there's a lot of focus on security. I think like it's so important. If you look at any of the talks that are given by our leaders, it has a component of security always. And the part where why people are not talking about security enough, I think one, there's obviously that differential between people building the products who are new to generative AI versus the experts in the generative AI field. And the people who are building products is like rapidly increasing, but the experts are like lower in number. So there's a natural difference in the amount of chatter happening in building versus like people who are thinking more about security, but that doesn't really translate into like people not thinking about it. The other aspect of this is the fact that a lot of the security research, because it is about protecting and making sure that the applications are not vulnerable, will also not be publicly disclosed. And I think I came in with a disclaimer about like how this talk is not going to be about any of the Microsoft products or and things that we are building internally to secure co-pilots, right? Is because that if we give out the secret sauce, I think it's easier to break in. So what is happening with the product development is also going to not be talked about as extensively. But that said, all of those learnings while building those products are actually translating into services that can be utilized for other product developments and how we can help the community. So I think the whole the Azure OpenAI links that I have pasted in the chat, it's not something that you have to go and use it, but I think like it's worthwhile to just even look through some of those examples, because this is like particularly what we have learned, and we are trying to make that generally available for everyone outside the company, because we know these are risks and we are trying to like educate others. So but that education will take time, just because how things are developing right now. I think that's just my personal take on this.
Okay, thank you so much.
May I have one more?
Sure.
So, in your example, you said there will be a detection loop. And I really wonder how you detect yourself that you're hacked. You know, it's like, should we check Twitter that we are hacked as a company, someone is making fun of us? Or like, you know, how you figure out that you hacked with LLM, since someone can say that, hey, write me a poem to your chat application. And then are you going to run another LLM saying that, hey, what is this output? And then how do you detect this?
This is one of the things that I cannot talk about. But that said, I would say like the internal, what I'll write it on the chat, what I termed as red teaming is like the first set of tests that you do as a group of developers and also as a group of just like product builders across the company is super important, because what you're doing is after you've built the product, you're trying to like intentionally inject into that product harmful, like ways of manifesting harmful content, or like, you know, like you said, like write a poem about something that is about like Nazis and like just appreciating them, like things that are like going to be awful and like offensive to people. You try executing those examples and do it on a large scale set, like do it like on thousands of examples and see like where is your application failing. That red teaming process right now is becoming like more and more important, because even before releasing it to the world and waiting for someone to detect the gaps in your product, it's important that you do your due diligence before releasing it outside. And I think that red teaming concept actually existed for security for a very long time, but it's only becoming so popular now because of LLMs, and everyone wants to build an application, but no one wants to harm anyone with that application, because otherwise it will be a reputational damage. So I think like even before detection, I think the focus is prevention, and the prevention is enabled using the red teaming framework. And let me quickly also share this metric paper that I had linked. This is like one of the papers that I think folks from Microsoft has written, but you will see a lot more papers that are coming out, because like I think my team is also like writing some right now. But this is a good example of like how you even think about like doing that red teaming, and like how do you do that automatically, because you cannot sit there and like manually write these prompts, right? So you have to think more of a scaled mechanism to do it. Does that help answer your question?
Yeah, absolutely. Thank you. Thank you.
So if nobody asks, I may want to ask another question if I'm allowed. Like doing something on an LLM is really strange when you compare it to like doing standard programming. In order to make its outcome, its performance reliable, you may need to spend a lot of tokens behind. So like things like an LLM asking something out to another LLM as a judge, or like reformulating the question. So an input prompt can trigger a lot of internal prompts and internal things, which makes it slow and expensive already. And as we know in security, there's always this like performance penalty, like inevitably included in security. So in LLM, just doing like standard things may cause a lot of like extra like computation, so on and so forth. Do you think, or what do you observe as the current situation is now about the performance penalty that the current LLM security approaches incur?
I think every LLM application one has a different way of like securing. So it is not necessarily that like a LLM is calling another LLM, but just basing it off that, I think like it's now being called as like an agent framework, like where each LLM call is called as an agent, and you can have like multiple interactions of it. Yes, it's very token intensive. And I like a personal observation is not every model is capable of doing everything. There's a reason why GPT-4 is still not being beaten by any of the other LLMs. Yes, they do well on the benchmarks, but the question is, are the benchmarks appropriate? That is a whole other conversation, because these benchmarks are being used as a mechanism of testing, which is fine, because we are all like I said, we are just scratching the surface. We need something to test against. But not all LLMs are capable of doing every task, right? So the goal is to figure out the right LLM or the right model, even if it's not a large language model, for your process, and use that, because like you said, there's obviously no marginal gain in rising on like basically utilizing more tokens and like raising costs. So if there's a specific product that you're thinking about, or like if there's specific application that you're thinking about, we can talk more about it. But I think like it doesn't always have to be like two LLM calls defending against each other, because at the end of the day, LLMs are probabilistic. So a thing that is not caught by one LLM may also not be caught by another LLM. So the goal is to not just think about like a LLM-based defense, but like think more deeply about like what exactly other kind of defenses can be utilized to prevent a certain kind of harm or security breach.
Thank you.
Cool. Any other questions? I'm also happy to share the slides. Like, do you think, should I just email you, Onur?
If you can email me the slides, I can share it with the audience. That would be great.
Okay.
Thank you.
Yeah, awesome.
So if there are no other questions, then we can thank Dr. Reshmi Ghosh for accepting our invitation and giving this amazing talk. Thank you for being here.
Of course. Thank you, Onur. It has been a pleasure. Thank you all.
Thanks.
Bye.
See you. Bye.
Bye.
So everyone, we will have the final presentation by Julie Cadini from Stanford University in 9 minutes. So she's going to have a very interesting talk on impossible language models. So please stick